In no particular order, our second avatar for the Phylum Protozoa is Amir Harun. Amir Harun is a 100-level student of University of Lagos. Now I have to be really careful about how I pronounce this name because he's really particular about it. Amir is male, by the way, and I have to specially give a shout out to him because he's one of the amazing people who are very dedicated to and supportive of this podcast. He was the very first colleague that I presented the idea of this segment to, and he was absolutely encouraging. He keeps giving me great ideas on how I can improve this segment and the podcast in general. He would always give me feedbacks and updates, and even make sure that at all times this podcast is still available on every streaming platform. So, Amir, if you're listening to this, first off, forgive me for murdering your name. And I would like to thank you very much for everything you've done. You don't just do it for Farida, you do it for everyone that's benefiting from this. And we all appreciate you very much. I know he will kill me for saying this, but Amir is not just an academic scholar, but he's also a poet. And his pseudonym is Prosperous Harun. He's absolutely good at what he does, so when next you see any write-up under that name, make sure you read it, because I assure you that it will be amazing. I don't stand rubbish.
Hi guys. I know you're wondering why I'm panting. You won't believe what just happened to me. I went to my neighbor's side to look for people to share this podcast with. And their dogs chased me. I'm sure you heard the noises in the background. They were barking at me and chasing me. I'm so tired. Don't tell me sorry. The only thing you can do to help my situation right now is to share this podcast with your friends so I don't have to look for more people. I need to go and rest. See you later, guys.
Honestly, between you and I really think that Jack is a drama queen. I'm sure you think so too. This is Amir Harun, and this is his classroom.
I'm gonna set your place on fire. Let's get higher.
Hello guys, I'm Amir Harun, a 100-level student of University of Lagos, Nigeria, a Unilag of course, and I want to talk about Protozoa. We want to look at Protozoa together, the subkingdom or the phylum Protozoa. The first thing to take note of is that protozoans are eukaryotes, like a misconception that they are prokaryotes. They are actually eukaryotes. They have a definite nucleus and the likes, but they are unicellular organisms, and you can trace them back to the protists. You get to know that the protists have some are photosynthetic, some are not photosynthetic, and others are like fungus-like. So, but the ones that are not photosynthetic are referred to as protozoa. So you have proto and you have zoa. Zoa is indicating to you that they are not photosynthetic animals. So like I said before, they are in most cases, or in every case, they are unicellular organisms. That is, they have one cells. But then we have others that live in colonies. So they can also be said to be one-celled. You understand? They are very small, and you can't barely see them with your eyes. In most cases, you get to use microscopes to see them. So like I said, they are unicellular organisms, but they are not very well developed. They have the organelles, but some of them are not well developed in the organisms. So unicellular organisms generally, in most cases, don't have tissues, they don't have organs, and there are no germ layers. They are just in the cellular stage. You understand? So just to check a few characteristics of them, some of them so like I was saying, that some of their characteristics, one notable thing is that most times they are found in aquatic environments, and that's probably to aid their movement and the likes. So like I said, that they are heterotrophic generally, but some of them can also photosynthesize. Like they have the chloroplast to manufacture their food, but those that can photosynthesize can also they can also get foods that are already manufactured. Just to move forward, most times.
Scholar, did your mind just wander away? Don't tell me it did. You can't be doing this now, Haba. Sit up, get up, wake up, listen well. If I catch you losing guard again, don't forget to show your love to this avatar by liking, applauding, sharing, and commenting below. Don't lose guard though. I've got my eyes on you.
They are characterized. They are categorized into four. As there are four common classes, and that we have the phylum Sarcodina, we have the phylum Mastigophora, we have the phylum Ciliophora, and we have the phylum Epicomplexa. I hope that is kind of clear. We have the Sarcodina, we have the Mastigophora, we have the Ciliophora, and the Epicomplexa. I would like to start with the Epicomplexa. Why? The reason is because it does not have these organisms in this class or this subphylum. They do not have a locomotive structure. That is, they don't have organs that make them move. They are not organs, or they are structures that enable their movements, their easy movement. So most times they are found in streams, like you can find them in blood platelets. So that's going to move them, and in other aquatic regions like moist medium generally. So they are parasitic, all of them, you can imagine, because they don't have structures to move, so automatically they would look for things to fasten themselves on, and so they can be transported to where they get their food, or to live, or to hustle generally. So they can reproduce asexually, and their mode of reproduction is via multiple fission, either schizogony or sporogony. I hope you understand. So the examples, we have Plasmodium vivax, then we have Plasmodium ovale, we have Plasmodium falciparum, and at this stage we should know that this is the most virulent causing Plasmodium that causes malaria. So I mentioned that they reproduce via multiple fission, either schizogony or sporogony. So schizogony basically means, it's a division of the cell, multiple divisions, while sporogony is formation of spores. So when spores are formed, and automatically the spores can be described to be zygotes, and they would later develop to organisms. So those are the ways by which the Epicomplexa, those are the ways by which they develop. Other examples, you have the Toxoplasma gondii, you have other ones. So there is nothing much per se about the Epicomplexa. Just to summarize, that is that about Epicomplexa. Moving on, we have the other subphylum, and that is the Mastigophora. So these ones, they have structures. They have structures for moving, and that is flagellum. While we can call them flagella, but it is flagellum when it's singular, and for the plural, either 2 or 3 or more than that, it is referred to as flagella. So, like I said, they are unicellular. So here we will see Iglena, and if you can remember well, Iglena can they can photosynthesize. So they have chloroplast, and that is why they can photosynthesize. But also they can also feed on already manufactured food. So they can be mutualistic or parasitic. So you get that they already have their own structure to move. So there is no reason to be parasitic. But in other cases, they can also be parasitic. So another example of the mastigophorans is Trypanosoma. Then we have the Leishmania, the Giardia. So Volvox is also a kind of mastigophoran, but it is a colonial species. So you get that it is not just unicellular. It is unicellular, but a colonial one. We can imagine how the colonial organisms look like. They are like, how do I explain? They are like mass of cell, but it's just one. They are categorized to be one because they are connected, and they are in most cases spherical. You understand? So Volvox is an example of mastigophoran. So the Trypanosoma is found in our bloodstream because they cause some kind of disease or infections to human beings. But basically, for us just to know, they move by the flagella. You understand? So that is that on the mastigorans. So we have another phylum also, and that is the Phylum Sarcodina. Phylum Sarcodina. These ones they move by their pseudopods, or let me say pseudopodia. So and there is a lot of examples. We have the amoeba, we have the entamoeba, we have the acella. But what is the pseudopod? You should notice at this point that the major things that characterize the protozoans are their organelles for movement. I'm saying organelles, not organelles. They are structures for movement. You understand? So the pseudopods, they move by pseudopodia, like I said. But this pseudopod, it comes about by like alternation of the cell cytoplasm. The cell cytoplasm of Sarcodina, it has like two structures, the endoplasm and the ectoplasm. The ectoplasm is like in a gel state, while the endoplasm is in a solid state. Like the solid state is more or less closer to being liquid, but it's not liquid, while the ectoplasm is also semi-solid but tougher. Let me say that, tougher than the solid state, the endoplasm. So when it alternates, it brings about these tiny projections that are very, very, very tiny. Actually, they are in thousands of millimeters. So it brings about these extensions, and these extensions are used to move. So that's knowing that the classification, like I said, is majorly based on the structures that they used to move. So the pseudopods, like I've explained, they are alternation of the cell cytoplasm from between the sol and gel states that brings about it. So, but there are different types. You know, the cell components of the organisms are very, very, very different. They are distinct. So the pseudopods also differ. They differ. So we have the logopodia, we have the philopodia, we have the reticulopodia and the axopodia. Logopodia they are kind of large and blunt, while the Philopodia are thin, Reticulopodia are also thin, the Axopodia are also thin, but they are being thin, they are also distinct. So like you have the Axopodia is long, not just thin, it's long, and it is supported by axial filaments, while the Reticulopodia is thin but it's joined by a mesh. I'm not sure you can get a picture. They are not long per se like in the flagellum case, but they are considerably long, but very small. They are just around the cytoplasm of the cell, like they are everywhere. Unlike the flagellum or flagella, that is just a projection, one or two projections that come from a part of the cell. You understand? So example of this, of the Sarcodina, the subphylum Sarcodina, we have the amoeba, we have amoeba, like I said, and the like. So they are not so much. So we have, which one again? We have the Acella and so on. So moving on, then the last subphylum we have talked about. The others, the last one is the Ciliophora. So they are also regarded as or referred to as the ciliate. So like I've said before, they are the major distincting or how do I put it? The major distinctive feature. Yes, I think that's correct. I can't speak really correct English. You have to pardon me, and I'm not even teaching English. I'm trying to explain the subject in zoology. So the Ciliophora, the major distinctive characteristics they have is their organelle, their movement structure. So they are also referred to as ciliates because they move by cilia. So it's very easy to relate. So, but these organisms, they are kind of unique in the sense that they have two sizes of nucleus, like different ones. They have two sizes. They have the macronucleus and the micronucleus. So when we have a nucleus, then you have a subnucleus. Let me put it that way. So that's another thing to distinguish between the ciliates and the other protozoans. So they, like I said, they move by ciliate, and the cilia is kind of longer. It's not as long as the flagella, you understand, but it is longer than the pseudopod. Like it is more conspicuous. When you check it, you will see it is more clear. It's clearer than the pseudopods. That's one. And also, but it has like almost same structure in the sense that the length, like we have it in some outlines or some documents. You can see that each part of their length, like it said, I'm going to paraphrase for you now. It contains 9+2 arrangement of microtubules called axoneme, which strengthens. So these characteristics, this thing that it has, flagella also has it. So they are similar in that way, but it is not as big, or let me say, it's not as big as the flagella. No, it's more than the flagella. It's much. It is not like the pseudopods that is all around, but it has a considerably large number. Like it's not just one, and it's not just 2 or 3. You understand? It is more than that, but it's not like the pseudopods that is all around the organisms. So examples of the ciliates, we have the stentor, paramecium, we have the vorticella, and the likes. So these organisms, in that they differ in their organelles, their movement structures, they also differ in the way by which they reproduce. I mentioned the reproduction of the epicomplexa. For the Ciliophora, they reproduce sexually and asexually. Sexually, they reproduce by conjugation. I hope we know what that means. That's very easy. And asexually reproduce by transverse binary fission. So So it's just binary fission, but it's in a transverse way. You get. So that is that on the Celiophora. So, but like protozoans generally, like I said, they are mostly found in like aquatic environments because they are important member of the aquatic food chain. They can be tiny, but they are very, very, very much needed. And in most cases, they exhibit symbiosis with themselves amongst, like a protozoan will exhibit a symbiotic relationship with another protozoan. You understand what symbiosis means, like commensality and likes. Why, like I mentioned earlier, some of them are parasitic. They are parasitic. You understand? Like the mastigophorans now, they can be mutualistic, and at the same time, some of them are parasitic. But like the epicomplexa, they are, in most cases, if not all cases, they are parasitic. You understand? For the fact that they don't have well-developed structures for movement and the likes. So I think that's it. I don't know if I explained well, but just a short recap. We know that the protozoans are members of the protists, but they are the they are not the purely photosynthetic protists. Like they are heterotrophs, although we have amongst them those who are also phototrophic, but at the same time they have the heterotrophic characteristics. And we know that they have certain general characteristics. They are very small in size, microscopic, and they don't have organs, they don't have systems, they don't have germ layers, and they have specialized organelles, even if they are not very, very well developed. And I forgot to mention we have a lot of them. Some sources classify them to be about 60,000 species, and that's a very large number of species. So they move by the pseudopods, they move by the flagellum, they move by the cilia, and the epicomplexa do not have a well-developed locomotive structure. So they can be free-living and they can be parasitic. And some of them that exhibit symbiotic relationship, they could be commensals and they could be mutuals. So another characteristic, general this time, they can be naked or they have protective exoskeletons. I think we should know what that means. But their exoskeletons are referred to as tests, like the test that we take in our classes or when we visit the doctor. So it is also referred to as tests, you understand. So the acella that I mentioned, that is part of the and the acella I mentioned, they also have tests. And another example that has tests is the difluga. You know that the acella is part of the subphylum Sarcodina. I hope we can remember that. So those are the general characteristics they have, and they reproduce most times asexually, but they also reproduce sexually, like I mentioned, for some organisms. So it could be through fission, it could be through budding, it could be by multiple fission, like I mentioned, that they have schizogony, and it could also be sporogony. So the sexual reproduction majorly is syngamy, orthogamy, and the conjugation. You know, the conjugation requires exchange of gametes, while the orthogamy is within a single organism when two gametes are produced, while the syngamy is within two different organisms, but they have two gametes coming together, but it's not there is no exchange of gametes. So that is that. We have the Sarcodina, and they move by the pseudopods. We have the mastigophorans, they move by the flagella. We have the third ones, and third one, they are the let me remember. They are the epicomplexa. The epicomplexa do not have a locomotive structure, and we have the ciliophoras, and they move by ciliates, or they move by cilia. Sorry, they are ciliates. They move by cilia, and so I think that's the best I can do. Not the best I can do. You don't have to pardon me. I'm not sure if I tried, but thank you very much. It's nice being with you, trying to explain one or two things, and I hope you enjoy the class. Thank you very much.
Make it move, make it groove. Make it move, make it move, make it groove.
The best test of knowledge is in the act of communication. Are you confident that you have read a topic very well? And are you sure that you have mastered that topic in zoology to its roots? If yes, then what are you waiting for? Slide in our DM and tell us you can explain. By doing this, you're not just helping others, you're certifying and verifying how well you are grounded with the topic. Once again, I'm Okoefa Farida, your personal online study buddy. And I would like to thank you for listening. By the way, Jack is somewhere in the background screaming thank you too. But his voice is too tiny, I'm sure you can't hear him.
Thank you for listening. I was busy commenting and sharing with my friends. I've shared to a lot of my friends and they love it so much. And I just want to keep sharing. I hope you have shared too. You know, we agree to share. I hope you have shared. So let's not be silent. Let's share it, okay? So share it with your friends. Like the podcast, comment, and like.
Okay, that's enough, Jack.
I'll see you next
Okay, that's
episode.
enough,
Bye.
Jack. Bye, scholars.
Episode.
Bye, scholars.